Scientific notation makes it easy to understand and to write numbers. Standard notation is the kind of notation we traditionally use when we're writing out something that has a lot of numbers in it. It might look something like that. Or it might look like, sorry, I'm going to put a few more zeros in here. When you're using these numbers with standard notation, it's kind of hard. You lose track of where the zeros are. You try to throw commas in to help keep up with it. You can't throw commas in when there is a decimal right there. So it comes into play, especially with extremely small and extremely large numbers. In chemistry, numbers that are like maybe up to 1,000, you may be asked to put them in scientific notation, but they don't have to be in scientific notation. And numbers that are like maybe to 0.0001 would also be numbers that maybe won't be asked to be put in scientific notation. So numbers that are just a lot larger or a lot smaller than that, though, should be put in scientific notation. It's really, really easy to do. So we're going to take this large number here, and we're going to stick it up there, and our small number. And all scientific notation does is it has you put a number down, just one number. It's not a zero. It's going to have to be something between 1 and 9. It's the first number you come to. So like in this one, it'd be this number is what you put down. Or in this one, it'd be this one is the first number you'd put down. So you put a number, and then there's a decimal, and then there's other numbers, just however many you need with significant figures. So there could be lots of those. There could be, 1 or 2 of them. It depends on the sig figs. And then it has a times 10 to the, and they always say times 10 to the, and then there's an exponent here. And that exponent is going to tell you basically how far you are from where the decimal was. So we'll do this first number. So I need the first number, the 7, and then the dot, and then I'm going to put the other numbers in, 5, 6. Now, this number as drawn only has 3 sig figs. There's no decimal in the number. Those other zeros don't count towards sig figs. Times 10 to the, and then I'm just going to move my little decimal over from the end. So 1, 2, 3, 4, 5, 6, 7 places is where that decimal ended up going. So that would be to the 7th. And then I'm going to go to my other number. And again, it's just the first number you come to, like when you're reading left to right. It's just the first number left to right. So that's a 2.5 times 10 to the, and then again, here's where my decimal started. 1, 2, 3, 4, 5, 6. It's a negative 6. So shifting the decimal right, that's what I just did. It makes it negative. Shifting left makes it positive. And just kind of a good rule of thumb is basically if you're starting with a small number, you're going to need a negative decimal because that means small. And if you're starting with a really large number, you should expect a positive exponent. So if you don't want to remember like the shifting decimal left and right rules, just make sure that when you're looking at the number you're starting with, if it's big, positive exponent. If it's little, less than 1, negative exponent.